Assalamualaikum. Hello guys. Today we will present about application of geometry. So we have chosen pizza and a Ferris wheel as the topic for our discussion. Okay, first of all, let me tell you about the similarities of these two things. So first, both share the basic characteristic of a circular shape. Pizza has a flat circular shape, whereby the outer of a Ferris wheel is in the form of a circle. Next, both have a center. Pizza has a midpoint, which is known as a pizza 7, while a Ferris wheel has a center, which is known as a central hub that rotates the Ferris wheel. Both have radius. Both objects has measurable radius, which is the distance from the center to the edge of the circle. For example, a slice of pizza forms a sector that can be measured because they are radi that meet at the same center. Meanwhile, Ferris wheel also has a spokes that meet at the center of the Ferris wheel, which is known as the axle. Therefore, both shapes were measurable radius. Lastly, they also have a financial-related properties. Although pizza is a static object and the Ferris wheel is a moving object, they can still be related to human interaction. For pizza, it is cut into slices and shared by several people, where each person takes a slice of pizza. As for a Ferris wheel, it accommodates groups of people, where each segment can be ridden by one person or more. So now, let's see the calculation of pizza and Ferris wheel. Let's go!
Now, 1 minute 37 seconds later.
I want to give up. I can't do this anymore.
Why, Marisa? What happened?
I can't seem to understand this topic. The formula are so confusing. I wonder, how can architect create plan for building?
It's okay, Marisa. Let me teach you. Alright, Mar, let's simplify the topic we are revising into a smaller scale. Let's take a Ferris wheel and a pizza, for instance. They have similar characteristics, so we can compare them to each other. I'll show you in terms of scale. If I were to say a Ferris wheel and a pizza has the diameter of 100 meters and 20 centimeters respectively, we are able to find the scale between these two items. All we have to do is change the units between these two items as shown in the calculation. Let me talk about some similarities that we can see from a pizza and a Ferris wheel. First, let's talk about the center of a circle. The center is the exact middle point of the circle. Every point on the edge of the circle is the same distance away from the center. If you were to fold a perfect circle in half in any direction, the fold would always pass through the center. Next is the radius. The radius is a straight line that goes from the center of the circle to any point on the edge of the circle. No matter which direction you draw it, the radius is always the same length. A circle can have radii, but they are all equal. Now let's look at the diameter. The diameter is a straight line that goes from one side of the circle to the other, passing directly through the center. The diameter is the longest distance across a circle. There is an important relationship between the radius and the diameter. The diameter is twice the length of the radius. In other words, if you know the radius, you can find the diameter by multiplying the radius by 2, and vice versa. Hold on, I know there's more, but let me ask Faris for help. Faris!
A few moments later.
When we discuss the distance that is the whole way around the outer boundary, or essentially the length of the crust, we discuss the topic of the circumference. The calculation needed in this instance is the formula 2 pi r. Okay, now we can move this formula into the context of a unique pizza and this formula for the circumference. As we know now, is applicable in the instance of our pizza that has a 20 centimeter radius. We now take the formula and calculate the multiplication of 2 pi, and 20. We find that the result is a 40 pi cm circumference and the whole length required for the dough needed for the perfect outer crust. After we finish calculating the outer boundary of the pizza, we now advance to the top part of the pizza that contains the toppings. The formula needed in this equation is the formula pi r squared. In this case, our 20 centimeter radius is now squared to 400. Our whole formula then is 400 pi, and the square units are measured in square centimeters. Alright, aside from that, we also learned about the sector of a circle. Imagine we divided the area equally, like pizza or a Ferris wheel, into 6 sections. Out of those 6 sections, we can calculate the value of each individual sector's angle. If we take the full 360 and divided it by those 6 sections, we find that each of the angle is 60 degrees. After that, we learn how to convert degrees into radians. By multiplying 60 with pi over 180, we get the answer in radians, which is pi over 3. By converting from degrees into radian in radian form, we have a more accurate value due to the use application of pi, and that's why we convert it into radian. After that, we can also find the specific arc length by using S equals r theta. By using this, we can compute r is equal to 50 meters and theta is pi over 3 rad. And then the final answer will be 50 over 3 pi meter. Next, we can also find the area of each sector by using the formula 1/2 r squared theta, where we know that the area for the sectors is 1250 over 3 pi meter squared. After that, for the area of the Ferris wheel, we can use the same formula for the area of pizza, which is pi r squared. After computing the value into the formula, we get pi 50 squared, which equals to 2500 pi meter squared. There is another way to calculate the surface area for the Ferris wheel by using the area of sector formula. To use this kind of calculation, we need to have the area of the sector, which we've already calculated, which is 1250 over 3 pi meter squared. After that, we are going to multiply it by 6 sectors, where we'll get the same value, which is 2500 pi meter squared.
Oh, I understand now. Thank you guys for helping me.
Since you guys talking about pizza, I feel hungry. Let's go eat pizza. I will treat you guys. Let's go.
Yeah, let's go. Our conclusion, we can conclude that the study of shape is not a simple or unimportant subject. Instead, it helps us to produce unique creation in various fields. Moreover, it helps to create attractive masterpieces for people to see and enjoy today.